All right, and then the last thing we're going to do is actually bring that data back into GIS and join it to the grid file so we can actually visualize the grid based on those values. Okay, so to bring in any text file, we use this Add Delimited Text Layer button. Click on that, and we browse for our data set. Here it's the trained set text file. Click on Open. It brings it in as a delimited text file with our headings and all of our columns. In this case, we don't want to represent it as a point file, even though we have latitude, longitude information. We actually just want to bring in the data just as a table, and then we're going to join it to the grid shapefile based on these IDs. So we're just going to click No Geometry, Attribute Only Table. Okay, let's click OK. So you see here it's brought in this table. It doesn't have any geographical information, but we have all the data in this table. And the last thing I'll do is I'll actually join this data to the grid file. To do the join, you just double click on the shapefile, and in one of these options in the layer properties you have the joins tab, and here you once you have the data imported into QGIS, you can click the plus icon, and the join layer here will be the data set. So we're going to go to trained set, and then the join field is the field in the data set which corresponds to the target field in this shapefile. Okay, so this is why it's helpful to keep these names consistent, because we can keep these both as IDs and it'll actually recognize that automatically. Okay, so click OK. It'll add that join field here. But now if we go to our attribute table, you can see that here was all the data from that's in the grid shapefile, and here's the data that was joined from the training set. Okay, because we had this common ID, it brought in all of these same values. Okay, so once we have that data joined, we can go to our style and specify the graduated style, and we can actually pick our prediction value that was joined from the data set. Here I'm going to go to equal count quantiles, and then just take off the stroke from our grid and hit OK. And here's our model. You see it predicted higher values for the center and then lower going out with some pockets. And you know, this is pretty general, right? The prices obviously don't follow this curve, but based on our validation, this is sort of the best model for our data. So it's not the ultimate kind of truth about the prices. Obviously there's a lot of variation, but this is the smartest kind of interpolation we can do. And we can also get in here and create more divisions, you know, to get a smoother contour over our prediction. Okay, and then the last thing I'll show you is this really cool feature. Because these data sets are dynamically imported into QGIS, right? They're not stored in this file, they're just referenced. We can actually update those results and then visualize them in QGIS. The only trick is this only works when you reopen the file, because QGIS will only re-import this data when the file loads. So if we save this as, I'll save it as start1 and close the file. So remember this kind of prediction. If we go back to our Python window and actually make some changes, so maybe we want a more detailed model, we can change some of these variables. And then if we keep everything the same, it's going to overwrite this text file. So I'll just hit run here. So it's overridden our trained set data file. And now if we open QGIS again, I'm just going to open that same file. We should have an updated data set. Okay, so it looks pretty similar, but if you remember, this is now a little bit more varied here. Okay, so this is a pretty quick way that we can iterate over several different models and then visualize them pretty quickly in QGIS. Okay, so that's the demo about using machine learning to derive these kind of smarter interpolations of values geographically. If you have any questions, please email me.